So in this reaction, we are going to place some copper 2 chloride solution onto an aluminum pan. They are going to be in complete contact with each other. As you can see, reactions are occurring. Okay, you've got this brownish nastiness coming out. Well, that's copper. That is copper metal. And as you can see, I'm going to now decant. Remember that word, decant? I'm pouring out the clear liquid. It was blue, and now it's clear. I am pouring out the clear liquid into the beaker, leaving behind copper. Okay, so this was an interesting demonstration. What did it involve? Well, you have aluminum, the aluminum pan. That it was a piece of solid. That is aluminum in its natural state. Aluminum is not diatomic, so it's aluminum. It's monatomic aluminum. And it is immersed in a copper +2 chloride -1, so that's CuCl2 solution. So this is an A plus BC reaction. It is single replacement. So what is aluminum going to replace? Is it going to replace copper, or is it going to replace chlorine? What you need to do is go to your activity series, which is in the back of your periodic table. You will find aluminum and copper on one end and chlorine on the other. You can only replace somebody that's on your own side. So aluminum cannot replace chlorine. Now, can aluminum replace copper? Well, we saw from the reaction, the answer is yes. But can it? Well, look at the activity series. Yes, aluminum is above copper. So yes, aluminum does replace copper. So on the other side, what do we see? We see that aluminum has been oxidized. That means its charge has gone up. And when its charge goes up, it goes up to +3. +3 is the only possible ion charge for aluminum. Chlorine stays -1. So you're going to need 3 chlorides to be exact. All chlorides, bromides, iodides, fluorides, they're all soluble unless they're bonded with lead-2, mercury-1, or silver. Aluminum is neither of those. It's not neither. It's not any one of those 3. And now copper has been kicked out into its natural form. Is it a diatomic? Is it a Brother Huncliffe? No, it's not. So it is a single agent, and copper, as in its natural form, is a solid. Is this balanced? No. This is not balanced. You need 3 chlorides. You only have 2 there. That is never going to balance. So you're going to have to even things out. How about if we put 3 times 2 is 6. 2 times 3 is 6. Okay, so the chlorines are fine. Well, that just messed up the coppers and the aluminums, but that's okay. 2, 3. So that is your molecular equation once you get rid of all the charges and all the little numbers and all this stuff. That's it. That is your molecular equation. What is your total ionic equation? Your total ionic equation is anything that is solid remains solid. Anything that is aqueous stays aqueous, but now in its ion form. So it's 3 copper plus 2s. You got to have that +2 there. I know we got rid of it there because that canceled out, but they're no longer canceled out. 3, is that 2 always with chlorine when it's part of an ion, or is it there because of copper? No, we put it there because it needed to balance out with copper. So that is not a permanent 2. That becomes a big number. So you have a 2, you have 2 3s. That's a 6. 6 chlorides, -1, aqueous. Yields 2 aluminum. Now it is an ion. plus 2 3s. That 3 is there to balance out the aluminum. So that 3 is a temporary 3, which means it comes down as a big number. 3 2s is 6 chlorides. And anything that is solid remains solid. So, in a double replacement reaction, usually you have two sets of ions that are spectator ions. But in a single replacement reaction, you only have one, and that would be 6 chlorides. Okay, so your net ionic equation is only going to have what is left over. So 2 aluminums plus 3 coppers will form 2 aluminum ions plus 3 copper atoms. All right, everything's nice and balanced, but let's prove it. Let's prove it, bringing into focus oxidation and reduction. Oxidation. Oxidation is when your charge goes up. Whose charge went up? Well, aluminum in its natural form, of course, is 0. Aluminum goes from 0 to plus 3. That's definitely going up. So let's put 2 aluminum solid forms 2 aluminum plus 3. So oil rig. Oxidation is losing electrons. Reduction is gaining electrons. How many electrons is aluminum losing? Well, it is losing, since it's going to plus 3, aluminum is losing 3 electrons. But there's 2 aluminums losing 3 electrons. So it is 2 times 3. 6 electrons being lost. Red cat. Oil rig. Oxidation is losing, reduction is gaining. So we will find electrons on the reactant side. So in order for 3 coppers to go from plus 2 to 0, they're going to have to gain electrons. They're going to have to become more negative, because right now they're positive 2. They're going to have to come down to 0. So you do that by gaining 2 electrons, but there's 3 sets of them. So once again, that's 6 electrons. So copper, in order for it to be reduced, has to gain 6 electrons. Aluminum has to lose 6 electrons. And that's how we balance this thing, using oxidation and reduction.